Check this out. We start with 440 inside and reduce our stake by half each time we win. After the first hit, our risk for the shooter is down to only $80. On the second hit, we're up $100. On the third hit, we're up $200. And from there, we just keep collecting our winnings. This strategy has some interesting properties. Most notably, on a per shooter basis, it wins more often than it loses. But if we don't win, those early 7 outs can do some damage. I wrote a simulation to find out how much this strategy can really win or lose. I'll show you my results so you can decide if you'd like to play this way the next time you are in the casino. But first, let's take a look at the strategy. We'll first wait for a point to get established. Once it is, we'll ask the dealer to place 440 inside. Great, we hit on the 8, so we'll get paid 7 to 6. That's $140 that we won on that one. And we'll reduce our bet by half to 220 inside. At this point, we only have $80 at risk for this particular shooter. There's another 8 that will pay 70, and we'll reduce our bets again down to 110 inside. This time the 9 hits, that pays 35, and it's time to reduce our bets again down to 44 inside. This is the lowest we'll go since we're on a $10 minimum table. From now on, we just collect $14 every time one of our numbers hits. The animation here shows that the bet comes down, but if you were at a real table, it would just stay up as you get paid. And there's the 7 out. We lose the $44, but ended this shooter up $215. The next shooter's point is a 10. We hit on the 5 and start the regression. Unfortunately, that one 7'd out relatively quickly. The third shooter makes a point of 5 and will get set up again. And we 7 out. That's a loss of $80 on this shooter. And the fourth shooter 7s out before we can even get our first hit. Those are the ones that really sting. I think that's enough for the demo. Let's do the simulation and see what the data looks like. Now that we understand the strategy, I'll simulate 100,000 sessions over 10 shooters. As usual, we have 8.5 million throws of the dice. That's because each shooter throws an average of 8.5 times. The total bet was 325 million, with 176 million won and $185 million lost. The difference of that is 8.6 million. That's the house take, and as a percent, that's an edge of 2.66%. But I have a hard time relating to this number. I want to know how it might actually feel when you're playing this strategy, so let's dive deeper. We'll first look at the data by shooter, and this is pretty cool. Over the million shooters I simulated, 56% ended with the player having won money, while only 44% ended with the player down. Those 44% can only be two outcomes. Either the player lost the entire 440 before hitting any numbers, or the shooter 7'd out before the player hit their second time. Any other outcome means the player's bankroll is positive for that particular shooter. Here is the histogram of outcomes by shooter. The x-axis is the amount won or lost over that shooter, and the y-axis is the frequency that happened during the simulation. 1 out of 4 times, the player lost the entire $440. Then almost 19% of the time, the players made exactly one hit. Those players are down $80 for that shooter. These two outcomes combined are the 44% we saw earlier. On the second hit, the players are up by $100. That happened 14% of the time. And the third hit has the players up by $201 for that shooter. The increments increase by $14 for each subsequent hit after that. And of course, longer rolls are more rare, so the frequency continues to decline. The maximum amount won for a single shooter was a very impressive $859. Now let's see how the strategy holds up across 10 shooters. In this view, 47% ended the session having won money, while 53% ended down. It's interesting to see how the proportions flip the longer you play. Those times when the player loses $440 do the most damage of a session, and that's what flips the overall edge to the house. Here's the histogram of those outcomes. The maximum lost over 10 shooters was $4,040, and the maximum won was $26.96. Our bins today are $500 wide. The middle group is almost evenly split between wins and losses, about 20% each with a small tilt towards the loss. Plus and minus $1,000 is going to cover 3 out of 4 outcomes, and over 99% of the sessions ended between plus and minus $2,500. Next, we'll examine the bankroll needed to survive all 10 shooters. This is a chart of each session's bankroll at its worst over the session. 30% were never down more than $500. 64% were never down more than $1,000. And 99% were never down more than $3,000. Next, let's look at the report card. We simulated 100,000 sessions of 10 shooters per session. The house edge is 2.655%. 47% of the sessions won, while 53% lost. And I made some changes starting in this video. I'm showing the actual percentiles for these ranges rather than using the bins from the histograms that we saw earlier. This gives more precision, But remember, this is not based on mathematical theory. These results are simply what was observed over 100,000 simulated sessions. The middle 50% of outcomes ranged from a loss of $672 to a win of $534. The middle 90% ranged from about $1,600 lost to $1,300 won. 99% of the sessions would have survived all 10 shooters with a bankroll of $25.25. As always, thanks for watching and good luck at the tables.